Hello there, this is Alan, back again, and this should be lesson 9 in the series. The title of this lesson should be, hopefully, called Building a Computer Program from Scratch. I'm going to get to what that means in just a moment, but first there are one or two corrections I want to make, at least one for sure. Not the last tutorial, but the one before that, and we were in the debug program, and I told you that this flag was called the direction flag. Well, it turns out that this flag, I looked it up, and it has a name, but it's not called the direction flag. It's called, in fact, the sign flag. Now, that wouldn't matter, except for the fact that there's another flag which does have the name direction flag, and it's not this one. So in order for you not to get confused, this one's called the sign flag, and the direction flag is this one. And you'll notice that it's currently saying UT, which in English usually means up, the way this arrow is pointing. And in fact, this has two values, and they represent up and down. And I also found out that you can set that one directly, and just by experimenting, I tried. Since it's called the direction flag, I tried this, set D, takes us to break, and CL, clear direction, took that as well. So here we are, let's see if it works. I don't know which way is set and which way is unset. Okay, so now I set it, and that means down. And when I clear it, that means up. Now, you can wonder for yourself what up and down could possibly mean, but there's only one meaning I can think of in terms of a computer, in terms of up and down, that is, and that's got to have something to do with memory. Are we reading from, if you think of memory as a block, you think of memory as a small block extending on, down forever, or stopping. So if this is memory, and here's 0, let's say, and here is the end of memory, however much memory you've got. And if you're reading or writing into this block, you could think of the way you're going in your writing or reading as either being up or down. So my guess is that this direction flag has to do with the direction of reading or writing to memory. I guess, I don't know for sure. In fact, there are a number of commands in the Intel instruction set, and let's actually remember the names of them, which are extremely concise. These are commands that do a repeated operation with a single command based on some parameter. Usually, you put some number in CX, and then you run the command, whatever they're called, and one might be read, or another might be write. But let's see if I can do it again. What a good memory. Okay, Now, if you see what that is a single command, only 2 bytes long, and well, it looks like 2. Maybe it is 2. What it says is repeat until not. Oh, now I remember. It is that. Repeat until. Repeat as long as the 0 flag is not 0. Well, it's not 0 right now. Load means load. S means source, and B means byte. Okay, and where's it going to go? That is what these 2 registers are all about. This is called the source index, and this is called a destination index. Now I had a bunch of junk here at 100. I want to change CX to 30. Not diverse. But I'm curious then. Okay. Now I want to load from 30, from 100, because we were at, after, what I dumped there was 100. What I need is a destination, or source pointer, to 100, and I want to put everything from 0 up to 30 offset from 100. I want to copy from here and put it somewhere else. So I want to swap for it somewhere. Okay, I'm going to fill up from 200 on. All I need is 30, but wait a minute, 200. From 200 to 240. Yeah. Oh, so we got some zeros here now at position 200. So I'm going to make my destination 200. Now, what it should do is, in the single command, it's going to, I hope, copy, and actually copy its own self, its own instruction, part of the work, from 100 all these bytes up to, but not including the 30th, so that's 3 lines, 3 times 10. Each of these lines has 10 X objects. And take from SR and put into DI. And that should be it in one time. I'll be as surprised to see if it works. But let's see if it happens. Load STO. Oh, that's not heavy. I want to store. I want the source to be 200 because we're loading. Oh no, that should be right. If we're loading into the destination. Now, let's see what happens. Run the command and see what happens. Is it completed? No. Well, it shows it's actually stacking. CX is going down. AX is doing something, but I don't think that matters. What I can do here is send it. I want to proceed beyond this to 1, stop at 104. Hopefully this will work. Go to 104. Okay. Now it's done. What happened was the CX eventually became 0, and so it quit. Now, the only question is, what happened over at 200? Nothing. It's something like, if you try reversing, Putting the jump into 100 would have killed us. And that's still what we have. Load as. I'm going to try a different thing. Repeat from 0. Store byte. Store the source byte. Oh yeah. And then after it. And I'm going to go to 4 again. Huh. Well, okay. Obviously, it's not reading. It's just storing something. A single byte. Maybe that's what the S stands for, single byte. It did go to our destination, that's good. And it probably did the same thing last time. Except this time, what was in the AX happened to be FF. Oh, load. Okay, that's why AX was changing. I see. Okay. I'm sorry for that frustration. We'll figure that one out later. Yeah, I've probably already wasted about 10 minutes. Now, I want to mention a couple of things first. What we want to do here is we're trying to design an actual computer program. I don't mean a batch script, I mean a native computer program. And in general, this tutorial series was initially called, and might still be called, Effective Programming in C++. And you might think that, what's that got to do with the little adding machine that we talked about last time? And it has, what I want to tell you is it has everything to do with that little adding machine. In fact, that little adding machine the example contains one of the principles that I wanted to talk about more, less talking about, but just by observation. Where did it go? It's in my done. Where I put things unfinished here. See, what we started out with. Well, first we started out with our idea of XOR and how maybe we could do an add. And then I told you that there are 3 things that we need in order to make anything, and what we wanted was XOR, but we don't have XOR, but we have these little building blocks, okay? The OR and the NOT and the AND. 3 circuits that somebody can make. Now, we found a way of putting all that together into this great complicated mess and that result came out to be XOR. Okay? So now this complicated circuit, which is actually, if I wrote this out in full, would contain all these circuits, is a great big complicated mess. It would be even more big and complicated if we included everything. Becomes just another little box. So what's happening is we're scaling things down. We're scaling out. What we have is what every programmer has. It's a little toolbox. Okay? And whenever you make something useful like this XOR thing, what you have to always do, and what I always try to do, and I'm telling you, I'm not suggesting maybe you should do this is add it to a toolbox. Okay? Don't repeat it. Don't copy and paste it somewhere else or something like that. What you take, if it's something that is of general use, you put it in your toolbox, and then that's done. You're done with it forever. So that's what we've done here. Now we go to this. We ended up over here. Now all that complicated machinery, which had that great big circuit, which included even more detailed circuits underneath, it's just its own little box. And here I've combined that box with another box. And now we have a new tool. So now we've scaled back again. And what we're getting here is a reduction in the complexity at one level. And then now we jump out again. And now we can build something another level higher of, let's say, equal complexity on this scale. That's the other thing. But if I included everything to do with all those other circuits in this diagram, well, you wouldn't even be able to tell what's going on. It wouldn't look like anything. And that's what the whole idea of what I call scaling the architecture is about. It's about taking something that does some task and then adding it to your toolbox, and then reducing that has the effect of reducing a complex operation into a single like a word, a command. Eventually we forget about and or not and all that stuff, and all we have is add. This here thing, once we chain it together, becomes an adder. And then, when we do that. Now we've reduced all that complicated circuitry into just these three letters, or in C, just that. It's such a basic operation. It's just represented by one letter. And an effective programmer, which is how would I define it? And here's what an effective programmer is. So I used to work for a company. It's basically this. An ineffective programmer is a liability. An effective programmer is not being a liability, but being an asset. So we should be an asset to the company, not a liability. And many, our company as well, companies employ people who are initially a liability, but you don't want to fire people, keep them on, and hope that maybe by osmosis or direct training, you can turn them into an asset. We had a few programmers that initially that were of no use. They were of negative use. They would turn things in code, untested, and cause all sorts of problems. But eventually they learned to catch on and became useful. One of the strategies for becoming like that is this whole building blocks rescaling idea. And that's what the adding tutorial was attempting to demonstrate. I'll probably have to make a new tutorial. I have to show you this example. I forgot to actually prepare an example from our poor old friends at SourceForge. Right now, a project that I am working on is I'm trying to basically rebuild one of their failed projects. They have a project called ID3Lib. Okay, and what it is it's a thing for MP3 files to change the information in the headers. You know, how you see when you see in the listing of or in Winamp or something, it'll tell you the author, and it might display a picture or some other information and whatnot. And all I wanted to do was, for myself, I had a whole bunch of MP3 files, and I wanted to change the ordering, you know, to set the numbers correctly so that they would show up correctly in the list. And I also wanted to put in some information, the author name, and so on. But I couldn't find any program online that did it, and except for a graphical one. But that was useless to me because there's so many files. I need to run a batch script to do it all in one command. So I need a command line program to do it. And I found this lib. And I started working with this lib. It was crashing all the time. So many problems. And then I found out that that project actually failed. They stopped supporting it years ago. But I didn't give up. I figured, you know, I'll take a crack at it. Maybe I can fix it. And I have actually fixed most of it. But in that project are some prime examples of bad coding practices. And one is the failure to rescale. The failure to add a tool, to take a useful thing and add it to the toolbox. And so therefore the complexity doesn't go down. It remains the same. You're always seeing all that detail that you don't want to see. You want to see the overall structure. And here's the example. Is it in here? Oh yeah, fail scale. So, now I noticed that most of the time when this was occurring, there's always this. The following routine courtesy of some guy's name, I like that. Okay? Now look at this function. Remove pictures, okay? Set number. Check if this is no. Go through the loop. Remove frames. Return how many removed. Simple function. Now, how much of this function has to do with the word pictures? If you look at it. It doesn't matter, you don't have to understand what the function does. But I don't see anything in here to do with pictures except for that. This is a general procedure that could be passed a parameter. If I just put an X comma here and pass it a parameter, now I've got a useful tool. I can remove any kind of thing according to this parameter. But they didn't. Instead, here's what you find. And this isn't the only function. There are about 20 like this. Remove track. Notice anything similar? Sure looks similar to me. Size T, num remove. That line's the same. Same, if no. Okay, they've added some brackets there. While frame. Not quite the same. Okay. Over track. Okay. So that's a little bit different. Remove the frame, delete the frame, increment the amount removed, and return it. Same function exactly. Alright? Look at this one. Size T, num removed. Same, except for This changed. Same. Okay, now imagine you're going through this file and you're trying to find something. And all you see over and over again are the repetitions of these same functions. Here's another one. Okay? All that's changing in all these functions is that parameter. What they failed to do was take a tool and put it in the box. They could have gotten rid of all this stuff. Well, this is a little bit more complicated, this one. This is combining two removes. Actually, you could just repeatedly call the other function with a different parameter. Instead, here we have it inside of another function. There's another one. And this one. I didn't even notice there's another one here. But there were 8, I guess there are 9. So there's number 8. And this one was 9. All the same. Now in that particular file, that's called MISC support, that the same person's name comes up. I think this is not including the other one. 1, 2, 3, 4, 5, 6, 7, 11 times. Now that person provided 11 functions, whoever they were, to this project. And for each of those functions, there are 9 or 10 versions, copies of those functions, all of them the same, in that same file, MISC support. Okay? Now, ask yourself a question. Why do you think the project failed? You know? It's not so much that there's nothing really wrong with this piece of code. It's perfectly fine. But nobody ever bothered to take a chance, take the opportunity, I should say, to make a set of tools. It does take a little bit of extra time, but that little bit of time taken saves you in the future so much time, not only in typing, but it allows you to see more of what's going on. And then I went to see, here I went back to the project folder to see what it currently is. That comes from an old archive. It's in here somewhere. Back to the source directory. And find path. What do I get? It doesn't even exist anymore. Turns out that whole file was full of so much repetition that after I cleaned it out and removed the repeats, there were so few lines that I could just fit it into something else. And so I think it was 50,000 characters worth of code was reduced to about 7 lines, and it's gone. So I actually, I'll stop here and I'll do the other tutorial in the next lesson. So call this comments or something. Thanks. Bye.